Good morning, everyone. How's it going? My name is Vijay, and this is
I'm
Niranjan.
Niranjan.
Okay. And today we would like to speak on artificial intelligence gone rogue, exterminating deepfakes before they cause menace. Everyone sitting in this room has an unique identity, which is defined by his or her face. The face is a crucial aspect of identity. So what if this particular identity is stolen from you and is misrepresented in form of videos? This is happening now, and as AI has so progressed, if that is trained well with sufficient sources, it can generate seemingly real, fake, and deceptive videos, which are known as deepfakes. So deepfakes are created to, or can be created to target people of interest or people of importance. And we would be looking a bit on that part. So before we start off with the presentation, I would like you to tell you about some disclaimer. First of all, the solution obtained from this research primarily focuses on videos which are created using face swapping techniques and portrait videos, and in which only one actor is observed. And the second thing is the presentation does not contain any code snippets. So it's really, even if anyone doesn't know anything about deepfakes, this is really good. This is the agenda. So deepfakes, what are they? What makes them so different? Some real-life scenarios in which deepfakes can be implemented or used against us in future. The ingredients required to create deepfakes. Cutting poison with poison, that's some use of fancy words. It's just a tiny, fast, and simple solution to curb deepfakes. And we'll be also looking at deepfakes through different aspects. This is like one of the researches which we thought to cite, in which the biological aspect has been covered, the limitations of that particular solution, and how does the future look in terms of deepfakes. With all that said, some valuable takeaways in form of black hat sound bites. So as I mentioned earlier, that deepfakes are created or can be created in order to target people of interest, people of importance like politicians, celebrities, and even common people. So it's not only to that part. And these videos are created in such a manner that they can fool human eye, and human can easily get tricked, believe what they see, or what actual the threat actor wants them to see or believe. So let me delve into the many hazards of deepfakes, what hazards deepfakes have. The very first is cyber propaganda. So imagine a scenario wherein a fake video is created of a politician, speaking utterly rubbish or passing obscene comments just few hours before the voting day. And then this video is uploaded and circulated over the social media. I guess this will obviously or potentially alter the outcome of elections, as people after watching this video will unknowingly go ahead and elect someone who is not capable enough. This is pretty scary when we see or when we talk about politicians, because this can create tensions not only within the country but also on a global level. Fake news equal to deepfake news. So not only in 2018, but we have been seeing from a past couple of years that politicians have been accusing news media channels of spreading fake news. So there are news here and around, and you read a lot about that too. So we believe that deepfake news will quickly replace fake news in the near future, where fabricated videos would be used. Turning over to trust issues. Now, deepfakes are rapidly progressing, as we are talking right now, and this can lead to trust issues. So even genuine online video content can raise or can invite suspicion and can raise questions to its validity. Uh, Politicians can simply flat out or cast doubt on genuine videos which have brought embarrassment to themselves, stating that the video is fake or fabricated. And there have been situations in that. I won't be talking deep into that. Moving over to disinformation campaigns. So the deepfakes circulated over social media can add fuel to disinformation campaigns. So this can turn into severe violence within different countries and even can bring out social unrest. Emotional distress. So the revenge pornographic fake videos, which are created using applications or using code, can certainly cause trauma, depression in one's life, and can even ruin his or her reputation and social standing. What if deepfakes become ubiquitous? So let's consider a hypothetical scenario in which a large volume of deepfake videos are uploaded and circulated over social media platforms, and people, so that people can watch and can make decisions according to it. The consequences are pretty scary. And the last one is virality versus legality. So, deepfakes become popular when fake pornographic videos of celebrities started making the rounds online. And this obviously violates the rules of consent, as well as the victim's rights to privacy. So deepfakes created using different applications, freely available applications, we believe that they can be a form of abuse to someone's life. So these were a few of the hazards of deepfakes. Now moving over, what it takes to prepare a deepfake. So all it takes is a gaming laptop, internet connection, some passion, and patience, of course, and maybe some rudimentary knowledge of neural networks. You obviously need a large data set of images, which are freely available, yes. As in the statistics say that in the year 2015 to 2016, there were around 24 billion photos uploaded over the internet. So you can easily grab those photos and videos. If you are thinking that if you don't have any knowledge about neural networks, don't worry about it. Some of the generous people have already eased up the process by creating applications which are available on various platforms, which help you to create deepfake videos with the help of one single click. So this is how a particular deepfake is created, if you don't want to work with code. And now I would be handing over to my friend Niranjan, who would be talking a bit about deepfakes.
Okay, thank you, Vijay, for walking us through different aspects of deepfakes and alerting us about their hazards. So now, as he said that there's only rudimentary knowledge required to create deepfakes, so let us get a sneak peek into how deepfakes can be created. Now, what we see in this image is a simple autoencoder. So an autoencoder has two neural networks. The first one is the encoder, and the second one is the decoder. So the encoder has the job of taking the input image and grabbing the essential representations and mapping it to a lower dimensional space, while the decoder takes it as the input and tries to reconstruct the image as accurately as possible. If you do it in multiple rounds, the network gets trained so good that you may not be able to get the difference between the original image and the reconstructed image. So this is the algorithm that is used to create deepfakes using face swapping technique. Now, to perform face swapping, we need two autoencoders. Now, consider you want to have face swaps between person A and person B. So by doing this, the encoder will get trained to pick up key features from person A's face. The decoder will also get trained to extract complex features from the latent representation of person A's face. So we trained the first autoencoder. Similarly, we will train second autoencoder on person B's face. Now, after training both the networks, we will just swap the decoders to get the phase swaps. Now, we all know that video is nothing but frames which are bundled together at a particular frame rate. So if we have enough computing resources and data, then we can easily do this and create a deepfake video. Now, with the ever-increasing data on the social media, it becomes very important to develop systems that monitor the quality of content on the social media. And now, as Vijay mentioned earlier, the presence of deepfake videos on the internet can skyrocket at any time. Therefore, we need a technology that has the ability to scan the content that we upload on the social media and flag it or block it. So we would like to share the results of some experiments that we carried out in confirming the authenticity of videos. Now, before we look into that, again, let us take a sneak peek into face recognition. Researchers at Google released a model called as the FaceNet model, which has an amazing accuracy of detecting human faces. Now, the triplet loss optimization function is the peculiarity of this model. Now, how does it work? Consider the anchor image as the image of person A, and the positive image is again the image of person A in some different setting, while the negative image is the image of person B. So the face recognition task is to identify the anchor image and the positive image as the images of the same person, while classify the images of anchor image and negative image as the faces of other person. So the FaceNet model, what essentially does is it gives the output of 128D encoding of any image and reduces the task of face recognition, which is complex, into a very simple task of finding the Euclidean distance between two vectors. So you might also remember unlocking your phone by just looking at it, or you might find your name against a group photo which you uploaded in the Facebook. So actually, this is the same technology which tries to identify the human face once it is trained to detect that face. Now, this is the block diagram of our solution. We trained the FaceNet model on a wide variety of images of people like politicians, celebrities, and sportsmen. We obtained the best possible FaceNet encodings for their images and stored them into a database against their labels. Now we come across a portrait. Now, when we come across a portrait video which is randomly picked up from the internet, then in the first step we break that video into frames and we process the video on a per frame basis. Now, for each frame, we get the FaceNet encoding and try to find if a similar encoding is already present into our database. Now, if there is a hit, then in the end, our prototype will give us the list of probability scores, which will indicate the possibility of that person being actually present in that video. So this might help in gauging the authenticity of the video. So a low probability score, which is less than 50%, might say that the video is fishy, or it might be a deepfake, while a higher probability score, which would be generally more than 50%, would say that the video might be genuine. Now, during our experiments, we used 26 deepfake videos that were openly available on the internet. And at the same time, we also used genuine videos of the same persons. We have recorded some successful classifications for the demo, and let's see the first one. Now, this is the GIF which we obtained from a video, and this is a genuine video of Mr. Nicolas Cage. Now, when we fed this video as an input to our prototype, we got this output. So our prototype says that there is 89.27% chance that the video, that Mr. Nick exists in that video. So there is a high chance that there's a high chance that this video might be genuine. Now let us take another example. Now this is the video which we worked on. This is also again a genuine video of Mr. Donald Trump. And when we fed this video to our prototype, we got this output. So there is 92% chance that Mr. Trump is actually present in this video. Now here goes the interesting one. So now this is a deepfake video. Now this was freely available on the internet. Now you can see that Mr. Trump's face is swapped with Mr. Nick's face. So now when we pass this video as an input, we got this as the output. So our prototype thinks that there's only 7% chance that Mr. Nick is actually present in that video. and there is no chance that Mr. Trump is present in the video. Now, for the simplicity of our implementation, we just worked on 4 encodings, which are present over here, and we represented the next class as the unknown. So now, we know that our network was trained on these 4 encodings, and it was our assumption that we will be only working on videos, either the deepfake videos or the genuine videos of these 4 persons. Now, the model says that there's only 7% chance that Mr. Nick is present, so this is fishy. Now, scope for improvement. We believe that there is a huge scope of improvement for our model, and we are constantly working on improving the performance. We believe that augmenting our solution with these 4 techniques will make it more effective. The first one is the state-of-the-art technology, which is used, which is the face liveness detection, which is used to unlock the devices using face recognition. And we believe that a slight modification to this technique and alteration to our problem will help us detect forging in videos. The second technique is the contextual intel mechanisms. Now, what this technique is actually, it will enable us to understand the video semantically by giving us information about what is going on in the background and providing us with more metadata, which will help us again in classifying the authenticity of the video. The third one is the texture investigation. Now, it is always observed that when deepfake videos are created using image manipulation, or in our case, face swapping, the forging leaves behind certain patterns. And the texture investigation techniques would help us in identifying those patterns and in turn help us in confirming the authenticity of the video. Now, the last one is a bit complex. It is user interaction. We have an intention to create a data set which involves videos which contain normal head rotation, smiling, and normal actions of humans. So after that, after collecting this data, we have an intention to train a deep learning model which will study the natural movements of human body. So now, when it is presented with a video, which is a deepfake video, it will be able to identify whether the movements done by the actor in the video are natural or they're not natural. So we believe that we are already working on these 4 pointers, and we believe that we might get some success, some better success than our earlier attempts. Now, there is no one solution fits all when it comes to deepfakes. So as you are all cybersecurity experts, we know that this is a cat and a mouse game, so it keeps going on and on. So therefore, I would like to discuss the merits and limitations of our approach. We believe that our solution can be scalable, and then it is again small, simple, and fast to understand as well. Now, face recognition technology has been there for a while. So we have Facebook doing a lot of things in face recognition, and they have a lot of infrastructure which is already there in the field. So instead of coming out with a new approach which needs new infrastructure, we believe that our approach could be improved and modified, and it could use the existing infrastructure to detect deepfake videos on the social media. Now, coming to the limitations, our current solution was produced to detect deepfake videos which were produced specifically by face swapping technique. So there could be other techniques as well to produce deepfake videos which involve some other methods other than face swapping. So this particular approach won't work in that scene. But again, as I said, we are constantly working, and we also have interaction with the international research community who are working with this problem. So now I request my friend Vijay to discuss some interesting solutions that have been found internationally to curb this problem. Thank you.
Thank you, Niranjan. That was interesting. So now, as I mentioned earlier, that we'll be talking a bit on a different research. We are honored, and we would like to thank the researchers at the University of Albany, US, wherein they looked at a different point of view. They looked at the biological perspective. What this research is that the researchers took this particular criteria of eye blinking, and the statistics says that the mean blinking eye rate when it's resting is 17 blinks per minute. So spontaneous eye blinking does not depend upon external efforts, or and it's very natural. While when we are conversing, it gets to 26 blinks per minute, and while reading, it reduces to 4.5 blinks per minute. The researchers use this combination along with the long-term recurrent convolutional network and went for the results. They determined or they identified videos in which there was abnormal eye blinking, and they termed as deepfake videos. So usually it is seen that the actors in deepfake videos do not blink at all, or there is very less amount of blinking, or the patterns are weird. Of course, there are a few limitations to this solution, as Niranjan, correctly
Yes.
stated that there is no one-stop solution for deepfakes. Yeah, this particular solution might not work properly if the video is of a very small length. That means it is less than a minute. There's no front-facing angle. Then there's again the scalability issue. And obviously, as Niranjan mentioned, that videos which are created without face tampering or
Tampering.
face swapping. I know it's difficult, but yet possible to create deepfakes wherein the eye blinking rate is kept normal. And just to add to this one, obviously the stats show that there are figures, the mean figures, but those can be changed or those can be deferred. Now, how does the future look? So, while you were talking, you mentioned a bit about some videos, which
Yes.
are created or which might be created not
Without
by
face tampering.
right, not without face tampering. So this is the next gen. We won't call it deep fakes. We will just call it in simple words as videos without face tampering. And this is amazing. I mean, as artificial intelligence, gets matured every day, it becomes better and better in producing genuinely fake content. So
Yes.
yeah, you heard it right. You heard the last two words right. This is a slide wherein this is a particular GIF image. The video is freely available on YouTube. On the right-hand side, it's Mr. Jordan Peele, one of the actors in USA. What he's doing is he's talking gibberish, and the same things, or the gibberish statements are coming out of former President Mr. Obama's mouth. So this is how the future might look, and this is pretty
Yes.
scary. If you have time, you can certainly have a look at this video. It's actually a 2 minutes or
Yes.
4
I
minutes
think most
video.
of them have already seen this video.
Yeah, and it was already discussed on different news channels also. Now it's time for some black hat sound bites. So one of the potential ways to curb deepfake videos is video watermarking. Basically, I'll move to the second point, which is very important, I feel. This is again, a kind of a social awareness point, which is think before you forward that video. So you should be careful enough. You should really, really think that whether this video is a real or a real or a fake one before you forward it to anyone else, or is it really worth to share it? The credibility of the source, you should also be looking at the source or the origin of the video from where it has come. See, we are not telling you to run any code, or we are not telling you to write any script to determine whether the video is a deepfake or a legit one. But what you can do is at least you can search it on Google, and
Most
Google.
of the times, crude human intelligence can also help in reducing the effectiveness of these things on the internet.
Right. And why we are talking about this is because we believe that deepfake videos created or targeted on politicians are of high concern, considering the fact of the next year mid 2019 elections, which will be carried out in different parts of the world. So just imagine if such kind of videos are circulated. In many of the countries, third world countries, sentiments play an important role. So people don't think before forwarding a video, and that can really instigate tensions not only within the country but also on a global level. We are also going to talk on the robust laws. So currently there are no laws or legal protection for individuals who have been victimized by deepfake videos. So there have been several news wherein people have become target for such videos, the revenge pornographic videos. So yes, so this is must. We should have laws in place for individuals who have been victims. And last but not the least, as they say in the famous, Game of Thrones, winter has already come, and the deepfakes in form of White Walkers have already approached. So we request the security community to come forward and to create
Spread,
a yeah,
create an awareness
right.
among the masses that such things exist in the world and they have power to manipulate our thoughts as well.
Or else what best we can do is we can at least create as many hurdles for the threat actors or for the malicious actors, so that it takes a time for them to create such nuisance or to
Yeah.
create deepfake videos. That's all we have for today. Thank you for joining. If there are any
Thank you.
questions, please feel free to ask.
We are here for the whole day, so you
Yeah,
can
please.
take the questions anytime you feel
Yeah, sure.
comfortable.
What techniques, I know very little about this subject. What techniques are there besides face swapping currently? Do they have any efficacy? Or do you think that in the future we'll have systems where if Star Wars can recreate Princess Leia, for example,
And
somebody else can?
actually, all the techniques that exist, they are AI-based techniques. So this particular one was autoencoders. There are many other techniques like transferring the expressions from one person's face to other person's face, but everything is AI. There are no non-AI techniques to do this. At least we don't know about them.
So researchers are, they have been working on different aspects of AI. Like they started combining or they started fusing
Yes.
up different AI models and then started working on these techniques. We are certain that this will proliferate in future, deepfakes. However, the solutions presented today and the solutions which are over the internet in form of white papers do have limitations, do have certain limitations. So we need to come forward and we need to
Yeah, I'd
move
like to
forward.
add to your point is that the thing is, researchers are developing this technology to do some good things, right?
Right.
So we are like everything which is invented in science, it gets abused by the bad people, right? So researchers are trying to create technology which can recreate dead people as well. So it has that power as well. But when it goes in bad hands, things get messed up.
Right.
Thank you. Any more questions? Okay.
Have you ever thought about securing video hashes in a blockchain?
Video hashes in blockchain.
There is a discussion going on the internet to use blockchain technology to solve this, but I didn't come across any research paper which had some solution like that. So we have some thoughts to work in that direction, but we are not yet clear how to proceed.
Do you guys see sort of like Apple and Google coming out with automating sort of watermarking on videos that are taken on your phone?
So currently, YouTube has got the concept of content ID. So what it does is when if I'm the creator or if I'm the owner of a particular video, when I try to upload it, it will check the content and it will verify if something similar exists or not, and then only it will allow me to upload that video. So that's their solution currently, content ID. Yeah. So that works pretty well. I mean, in order to avoid copyright infringement or violations, that is done.
Thank you. Any more questions? Okay.
Thank you so much.
Thank you.
You can reach out to us on the Twitter handles. Thank you for joining the talk.